Hi, I am Sam, your teacher, Sam my teacher, Sammy teacher. I made a right circular cone. A right circular cone has a circular base and the vertex, the point on the top of the cone, is right above the center of the base. Now I'm going to cut this right circular cone twice. Once and twice, with both of the cross sections being parallel to the base of the cone. And I created 3 different solids with the same height. And I named the first solid Solid A, which is a small cone. And I named the second solid, the middle one, Solid B. And I named the third solid, the one on the right, Solid C. Now, here goes my question. What is the ratio of the volume of solid A to the volume of solid C? Why don't you give a try? I'll give you some time. To give the answer to the question, instead of thinking of the 3 solids all separately, it will be much easier if you think of them as 3 different cones. A small cone, a medium cone, and a large cone. The small cone on the left is the solid A itself, and the medium cone in the middle is a combination of solid A and B. And the large cone on the right is the combination of solid A, B, and C all together. Notice that their sizes are different, but their shapes are all the same. So they have different sizes, but the same shapes. And when you have 2 or more solids that are equal in shape, you call them similar solids. And I'm going to give you a very important idea about similar solids. For any similar solids, if the length ratio is A to B, then the area ratio will be A squared to B squared, and the volume ratio will be A cubed to B cubed. Let me give you an example for that. Let's say we double each side of this cube so that the length ratio of the original cube to the new cube is 1 to 2. Then you see the area of each face of the cube becomes 4 times because you have 4 of the small squares on each face. And the volume of the new cube will be 8 times the original cube, since you see 8 of those smaller cubes. Now, by increasing each side of the original cube by 3 times, you now see that length ratio is 1 to 3, since each edge became tripled. Then, the surface area ratio will be 1 to 9, because each of the faces became 9 times. And the volume ratio will be 1 to 27, since you have 27 smaller cubes altogether. 9 cubes on the top layer, 9 in the middle layer, and 9 more on the bottom layer. Now, let's talk about the ratios of these 3 cones. First, the length ratio of the small cone to the medium cone to the large cone will be 1 to 2 to 3, because each of the solids A, B, and C had exactly the same height. And since the height of this medium cone will be twice the height of the small cone, and in the same way the height of the large cone will be exactly 3 times of this small cone. And now that we know the length ratio, we can also find the surface ratio of these 3 cones by squaring each of the numbers in the ratio. So the square root of 1 is 1, square root of 2 is 4, square root of 3 is 9. So the surface area ratio of the small cone to medium cone to large cone will be 1 to 4 to 9. But the ratio we are more interested in to find the answer to the question is, of course, the volume ratio. And the volume ratio can be found by cubing each of these numbers. So 1 cube, 1 multiplied 3 times is still 1. And cube of 2, which means 2 being multiplied 3 times, will be 2 times 2 times 2, 8. And cube of 3 will be 27. So the volume ratio of these 3 similar cones is 1 to 8 to 27. So if the volume of this small cone is 1, the volume of this medium cone will be 8. And the volume of the large cone will be 27. And since our mission was finding the ratio of volume of A to volume of C, and knowing that the volume of A is 1, we can write 1 for the numerator, and I just need to find what the denominator will be. And if you look at the large cone, we see that we can find the volume of the solid C by subtracting this cone volume from the whole thing. And as you might have noticed, that's the same thing as the medium cone, which has volume 8. So the volume of the large cone, which is 27, minus the volume of the medium cone, which is 8. So 27 minus 8 is 19. That gives you the volume of the solid C in the bottom. So the answer will be 1 over 19. And that's the ratio of the volume of solid A to the volume of solid C. This idea might have been a little difficult, but it's really important in many math courses. And I hope you understood my explanation. Thank you for watching and listening. I'll see you next time.